AI connectivity. When we think about AI connectivity, many of us first leap to an AI gateway. Basically, I have an application that I want to integrate with an LLM, and how do I get some security and consumption controls around that? And that is a critical use case. But I'll also say that there are two other use cases that are critical when you're setting your strategy around how you're addressing AI connectivity in your organization. Of course, the AI gateway use case is there, but you also need to consider whether or not you're going to be hosting any internal models, perhaps open source models that you're hosting in your own infrastructure, and how you're going to route to those models. And more importantly, from an agent use case, how you're going to have support for protocols like A2A and MCP when agents are talking to other agents and talking to tools. So let's map this out real quick and take a look at what these architectures look like. So the first use case, of course, is the one that we're all familiar with, is that I have an application I'm hosting, and I want that to talk to one or more external LLM providers. And what I want to do is I don't want to connect, and we'll have a separate video on this, on why you would use and the top use cases for an API gateway. But let's just accept for a moment that I don't want to connect that application directly to the LLM provider. What I want to do in this path is insert an AI gateway here to do things like token-weighted rate limiting, consumption controls, credential management, guardrails, and that type of thing. So super legit use case, both for applications and for agents. The second use case I mentioned is if you now or in the future are going to be hosting LLMs internally within your own infrastructure, perhaps in a dedicated platform. In that scenario, you have another direction of traffic, which is ingress traffic to those LLMs. Existing gateways, like API gateways, can't handle the advanced routing characteristics that these LLMs require in terms of if they've been fine-tuned, let's say with LoRa, how you're choosing the right pools of inferencing. If you're separating, perhaps with VLM and LLMD, prefill and decode stages of inferencing, how the gateway is aware of how to route between those stages and coordinate that activity. There's some very, very deep mechanics that you need to be aware of once you go and start hosting models and serving on your own infrastructure. And then finally, you have the use case where I have an agent. And that agent is actually going to talk to LLMs, where an AI gateway, of course, is useful. It's going to talk to tools, and that's going to be through MCP. And then, of course, it's going to talk to other agents via A2A. And this is a distinct use case, both from the ingress use case and the AI gateway consumption use case, because of the new protocols at play here with MCP and A2A. More importantly, with MCP in particular, this is a stateful protocol. And in most organizations, you'll be federating and virtualizing multiple tool servers to present the right set of tools to agents for a given use case without overwhelming them with too many tools. Existing API gateways and proxies in the market today cannot handle this new level of sophistication at a protocol layer that we commonly refer to as layer 8 above, like HTTP transports, for example. This is why we built Agent Gateway from the ground up to handle these specific protocols for A2A and MCP. But let's pull back for a moment, because I just talked about three key use cases. We talked about the ability for ingress on how I'm routing to models that I'm hosting on my own infrastructure. We talked about egress and how I'm actually going to control my applications that are integrating with LLMs and adding security, observability, and governance there. And then we talked about an east-west traffic pattern, where I might have an agent interacting with other agents or tool servers, and I want the same controls in place with context awareness for A2A and MCP as protocols. Now, these present as three independent use cases, but they can all be solved with a single, uniform, and consistent approach with Agent Gateway.